Hi guys, welcome to the Pepcoding. In this video, we are going to solve search in rotated sorted array. So we have given an array and a target. We need to find is the target available in the array or not. If it is available, we need to return the index. If it is not, we need to return -1. So this is the question. Let's see. Let's say we have a array like this. Here we can see it is rotated from the point here. Let's say we have a sorted array 1, 2, 3, 4, 5, 6, 7 and 8. Now if we want to rotate it by 3, these 3 elements will go to the front of 1. So this will be like 6, 7, 8, 1, 2, 3, 4, 5. So we have given the data in this form which is rotated and sorted. So we need to find the data from this. Let's say we have a target that is 3. The index is 9. How will we get this? If we do a linear search from 0 to the length, if we find the target, we will return the index that is 9. Now it takes of n time to iterate all the elements. So for finding an element in the array, if we do iteration from 0 to 9, it will take of n time. Can we do this in a better approach? Yes, we can. How? We can do this in of log of n. So for searching any element in a sorted array, we can use binary search. This binary search will take log of n time to find the data. So exactly we are going to use this binary search. Let's see how will we use this. Let's say we have a target 2. Now put the low here, high here. Find the mid. Mid is 0 plus 9 divided by 2, that is 4. This is the mid. Now is the mid equal to the target? Here we can see mid is greater than the target. If the array is sorted, this target will be in the left side of the mid. So we need to move our high to the mid -1. But here one thing, is 2 available in the left side of the mid? So for checking this, here we can see it is 5 to 9 from the low to mid, and which is not in the range of the target. If we say we have low that is 5, this is at 5, it should be less than or equal to the target, and the target should be less than or equal to the mid. Here mid is 9. If the target lies between them, so we can move our high to the left so that we can get our target. But here the case is our element is not in the range, so high will be on the last, but low will go to the mid +1. If this part is sorted, this means the target can be here, but here the target is not in the range of the left part, so the target can be in the right. So we need to move our low for discarding this left part. Low will be mid +1. Now here low is at 5. Again find the mid. Now mid is 5 plus 9 divided by 2. Here we can see now the mid is 7. This is 7. Now again check the target. Target is 2. The mid is 7. And the mid is smaller than the target. This means we can get the element in the right part. If it is sorted, the larger value will be in the right part. So we will move to the right. But before moving to the right, we need to check is the right portion is correct for moving. Is my data available in the right portion? So for this we will check is array of mid is less than the target or equal to the target, and target is less than or equal to the array at high. If this is true, this means we can get the data in this part, that is in the right part. If this is false, this means we need to move our high to the mid minus 1. But here this is true because our target is in the range. So our low will move from here to mid plus 1. This is the low. Now again find the mid. 8 plus 9 divided by 2. This is 8. Now at the mid, this is the mid. At the mid, data is found. So we will return the index, that is 8. So let's see what are the conditions. If array at mid is equal to the target, this means we get the element, we will return the mid. Else we need to check, is my left side is sorted or right side. If my array is sorted and rotated, so there can be only one part which will be sorted from the mid. Here we can see mid is this, then this part is sorted. If mid is this, then this part is sorted. Now else if we need to check, is array at low less than equal to array at mid. If this is true, this means we got the we know the sorted area. So we need to move our high to the left, mid minus 1. But before that we need to check, is my target is in the range. For checking that, we need to check, is array at low is less than equal to the target, and is my target is less than the array at mid. If this is true, this means our target will be in the left part, so we will move our high to mid minus 1. If this is false, this means we need to go to the right side, so low will be updated by mid plus 1. Else if array at mid, that is the array at mid less than equal to array at high, this means my right side is the sorted area. Now we need to check, is the target in the range. From this, array at mid should be less than the target, and array at high should be greater than or equal to the target. If this is true, this means we need to move our low to mid plus 1. If this is true, this means our target is not in the range, so our target will be not there. So we will move our high to mid minus 1 for discarding the right part. So hope you understand this. Let's code this. Now what we have and what we want. We have the array and the target. We want low and the high. High is array dot size minus 1. Now this is the binary search. Low is less than equal to high. Here we will check the mid, and mid is equal to low plus high divided by 2. Now we will check, is my array at mid is equal to the target. Yes, if it is, then we will return mid. If this is false, this means we need to check the second condition, that is array at low is less than equal to array at high. This is for checking the left side is sorted or not. If it is sorted, we will check, is my target in the range. For checking the range, our target should be greater than or equal to the low, array at low, and target should be less than array at mid. If this is true, we will move our high to mid minus 1. This means our data will be in the left part from the mid. Else this means we need to go to the right side. This is mid plus 1. Else if my right side is sorted, for checking that we need to check array at mid is less than equal to array at high. If this is true, we will check is my target in the range. For checking that, array at mid should be less than target, and then target should be less than equal to array at high. If this is true, this means our target is in the range in the right part. So we will move our low to mid plus 1, else this means our target is not there, so we will move to the left part. For moving that, high will be updated by mid minus 1. If we got the element, we will return the mid. If the element is not in the array, we will return the minus 1. So let's run this. Rejected. Let's see why. Here we have started the loop from low to high. Low should be less than equal to high. We have the mid. We have the target. If array at mid is equal to the target, array at low should be less than equal to array at high. Oh, this is array at mid. We are checking the sorted part from the mid. So let's run this now. So it is running. Let's submit this. So it is accepting all the test cases. So we have done this in log of n by using binary search. Let's take this for a simple try run. Again, let's take a rotated array 5, 4, 6, 1, 2. Now let's say we want to find the target 3. Here 3 is not available. Now low is low is at 0, high is 0, 1, 2, 3, 4. That is 4. First we will check low is less than equal to high. Yes, it is. So while loop will be start. Now for mid. Mid is low plus high divided by 2, that is 2. Now at 2, the target is less than the mid. So this means there can be possibility that it is in the right side. So we will check is there is the probability that our target is in the left side from the mid. So here we will check is my left side is sorted. This condition will check this. Here low and the mid. Here low is less than the mid. So this condition will true. Now it will check is the target in the range. Here we can see target should be greater than the low, but low is at 4, low is 4 and target is 3. So this condition is false. So it will update the low by mid plus 1. Now mid was 2, low will be 3. Now again it will check the mid. Mid is 3 plus 4 divided by 2. This is 3. Now we are here. This is the mid. And low was also here. Now we will check is array at mid is equal to the target. Here target is 3 but mid is 1. No, it is false. Now we will check is my array at low is less than equal to array at mid. Yes, it is true. It is low and mid are equal. 1 is equal to 1. So we will check is it in the range. Array at low should be less than equal to target and array and the target should be less than array at mid. Now here we can see low is 1. 1 is less than equal to 3. Yes, it is true. But 3 is less than equal to 1. It is false. So this condition will false. Again low will be updated by mid plus 1. Now mid is 3. Low will be updated by 3 to 4. Now here low is at 4 and high is also at 4. Now we will check again. Mid is 4 plus 4 divided by 2. This is 4. Now mid is 4. Mid is here, high is here, low, and mid is here, low is here, high is here. Now we will check is area at mid is equal to the target. Here we can see it is not equal. Now we will check is area at low is less than or equal to mid. Yes, it is true. Now is the target in the range? No, it is not, because we can see 3 is greater than 2 but not less than 2. Now it will update low to mid plus 1. Mid was 4, low will be 5. Here the condition is low is less than or equal to high. This will fail and it will return -1. That means the target 3 is not in the array. So this was a simple try run for a simple test case, and code is working fine. Hope you understand this. Please like the video and share the video. Thank you.